Hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic maximum and minimum points. We're talking about maximum and minimum points. But before this, let's take a big review at previous lesson. Okay, welcome back. Now, when you talk about maximum and minimum points, I know we are conversant with the word maximum and the word minimum. Maximum means a point that cannot be surpassed, while minimum means the least attainable value of any occurrence of any standard. Now, we'll talk about maximum point and a minimum point, and there's some criteria we really need to take into consideration before we go into detailed analysis of this, and this happens to be some of the rules that governs maximum and minimum point of a given equation. Now, the points on a curve at which, okay, this is dy, the x is equals 0 are called the stationary point. When dy over the x is equals 0 are called the stationary point. So at any given point, if an equation is being given to you at the point where dy dx, that is the differential solution of that equation, is given to you as 0, then that point is known as your stationary point. Now, stationary points fall into three different categories. So we have the maximum points, we have the minimum point, and we also have the point of inflection. This is the maximum point, this is the minimum point, and this is the point of inflection. Now, those in which dy dx changes sign from positive through 0 to negative, these are called the maximum point. The point at which dy changes from positive through 0 to negative. So each time your value of dy dx, that's your rate of changes from positive to negative, then that point is called your maximum point. We'll get to prove this as we proceed further. Now, at the point where dy over dx changes sign from negative through 0 to positive, these are called the minimum point. Those in which the sign dy over ds is not changing or does not change in the immediate neighborhood of the stationary point, these are called the points of inflection. We'll go further into analyzing it, but when you talk about this, I would like to give you a diagrammatic presentation of the maximum and the minimum point of every given chart. Now, let's talk about the maximum point. If you have a chart of this nature, let's say coming from here, let's call here our point C. Any point lower than C is called the minus C, and any point that is higher than C is called C plus. That's C and above. Let's deal with this point, the internal chart of it. This is our y-axis. Let's say this is our x-axis. So when you have something, and this should be an equation of y equal to fx, because we are still dealing with equation for you to differentiate. Now, stationary point, as we know from our previous explanation, talks about the point where dy dx is equal to 0. So when you have this, you discover that at fx, the equation, it should be an equation y equals to fx is what we are considering. So in the spirit of considering y equal to fx, fx. Now we say at this point, this is the negative part and this is the positive part. So if this is the negative part and this is the positive part of C, then this point is called the zero part. And it's at this point that the value of C changes from negative to through 0 to positive. So at the changing point is what we call the maximum point, which is this place. And at this point we are meant to know that dy dx is equal to C. So that is to say, at point C minus, dy dx should be less than 0. It's less than 0 because it's at this point. And at point C plus, which is this, the value of our dy dx is greater than 0. So it is only at point C, at C, that dy dx is equal to 0. But since our value starts, because this is the origin and the curve is coming this way from the negative coming towards the positive side through the point where x is equal to 0, now our area of interest is considering the stationary point before determining which point is maximum or minimum. So since this curve is coming from this direction, which happens to be a minus C, travels through this arc to this direction, and at this point is 0 point and is changing. Now remember, at every point where dy dx is 0, that's our point, that's our stationary point. That's our stationary point. We use this to solve series of questions. It happens to be a stationary point. Now when we take the stationary point, which is this point, then we consider in determining if it's a maximum or minimum. You know, when a curve is a parabola facing down, it originates from this point to 0 point. So this arc goes from the negative through the positive at this point. So there is the maximum point. And even if you look at the nature of the curve like this, you discover that here is the highest point that is attainable at this age, at this state. So this is the maximum point of this curve. Now when you have a curve of this nature, now let's take 3 points. Let's not use C in this. Let's use maybe A or B. Here, here, and here. We are dealing with here. We are dealing with this point. These are 0 mark. Let's say these are y and these are x. So remember, let's use B. Let's make use of B. This is B minus and B plus. Now taking a good look at this shape, you discover this is the least point. And the relationship between here and here came together at this point. So, and this curve goes this way because it's going from the positive B to the minus B. And at this point, you discover that at point B, dy dx is equal to 0. Remember, this graph is a function of y equals to f of x. That's what we are dealing with. So at point B, dy dx is equal to 0. So this point is a stationary point. Stationary point. Now at point B plus, that is at B plus, dy dx is still greater than 0. So it's never a stationary point. While at B minus, dy dx is less than 0. Because if this is 0, anything in this direction is minus, anything at this point is positive. And this is the point where it's equal to 0, and that's our area of interest. So this point, this is for minimum value. This for minimum value, and this for maximum value of x. So finally, let's talk about the stationary point. Now when we talk about the stationary point, we use two different graphs to explain the stationary point. Now the stationary point, we stated in our previous that those in which the sign of the y does not change in the immediate neighborhood of the stationary point is called the point of inflection. So the stationary point, we are considering inflection. It does not change at its neighborhood. So that's to tell you that it looks like this. Since it doesn't change, it looks like this, and drops down. So we have points like here, we have points here, and we have this point. And if it is coming from the lower region, you can still do it like this. It looks like a wave, where here is here, and here is also the higher point, and we have here. So these 2 points, let's call this A minus, A, and A plus. Let's call this B, B minus, and B plus. Let's call this our Y and the X with the arrow sign. So in trying to explain the stationary point, you discover that when you're talking about when we did something about the maximum and minimum point, we had just a curve, because those value changes, and if they change from here to here, they are not returning back to this position. But one thing about the stationary point is that it changes to this point, goes up, return back to it. That's how it will continue falling back to it. But the stationary point is a point where this point, the intermediate or the middle point between two occurring points at the middle. So that is what we use in identifying the stationary point. So this point is called the stationary point, and this point as well is a stationary point, because it's in between. These two levels are of equal height, and these two levels as well are of equal height. So the middle point between them is called the stationary point. So this is our stationary point, and this point serves as stationary point. So thank you for joining us in this lesson. So to refresh your memory on what we've just discussed, please take the test that will appear very shortly on your screen, and do well to use the lesson notes on the platform for better information on the topic we've discussed. Thank you.